Hello, this is the presentation for Group 7, and the topic we did is soil chemistry. My name is Michaela, and I worked with Jordan and Trin on this presentation. So what is soil chemistry? Soil chemistry is the study of the chemical characteristics of the soil. Some of these chemical properties or characteristics that we looked at were acidity, flammability, toxicity, and the reactivity of soil. So first, the acidity of indoor soil. So as we know, the acidity of soil and other things is measured through pH. And according to almanac.com, houseplants in indoor soil have an ideal soil pH ranging from 6.0 to 7.0. Next up is the flammability of soil. So in this one, we compared agricultural soil to indoor potting soil. So agricultural soil is less flammable than potting soil. And the flammability of agricultural soil is mostly dependent on the dryness of the soil and some of the chemicals that are sprayed on it or mixed in with it. And then some of the reasons that potting soil is so flammable, more so than agricultural soil, is because of the additives inside of it that are mixed in. And some of those include peat moss, shredded wood, bark, styrofoam, and vermiculite. Right, and then after that, we looked at the toxicity of soil. So these indoor and agricultural soils are pretty similar in this. They can both be contaminated with pesticides, petroleum products, radon, asbestos, lead, chromated copper arsenate, creosote. And this toxicity not only affects the soil, but it can transfer to food that is grown within it or plants that are grown in it, and then in turn can affect, either animals that eat that food or even people who eat the food or, could interact with some plants, smell some flowers, something like that. And then the last chemical property that we looked at was the reactivity of soil. So one type of soil reactivity looks at how soil reacts and changes to different moisture contents of the soil. So this graphic just shows how they classify it. So class and then a letter, sometimes a number, just kind of goes over how they classify each soil and then based on the moisture content and how it changes as the moisture changes. And next up we have Jordan.
pH in soil agriculture. pH is very important because it controls many biochemical and chemical processes operating within the soil. It is a measure of acidity or alkalinity. It regulates plant nutrient availability by controlling and influencing nutrients and their chemical reactions. This means soil and crop productivities are linked to pH. The ideal pH for most agriculture is between 5.5 and 7.5. Ion exchange in soil agriculture. Ion exchange is the movement of cations, positive charged elements, and anions, negative charged elements, through the soils. The total amount of positive charges that the soil can absorb is cation exchange capacity, or CEC. CEC impacts how quickly nutrients move through the profile. Soils with low CEC are much less fertile because they can't hold as many nutrients. Absorption in soil agriculture. Soils can capture different nutrients with ions. Absorption is the process where one substance takes up another. Soils with high absorption can take up extra environmental contaminants like phosphorus. Absorption can cause precipitates to be formed by nutrients or chemicals in the soil, transforming them into a solid.
Okay, let's talk about the precipitation of the soil agriculture. So agriculture production depends on weather. Rainfall can either encourage growth or develop crops. Cool temperatures and springtime rains can hinder planting and seed growth, just as hot temperature and drought can adversely stunt growth or kill mature plants later in the growing season. Soil is also greatly affected by rainfall. If it is too wet or too dry, nutrients in the soil can run off and not make it to the plant root, leading to poor growth and overall health. Additionally, as mentioned Overwatering or too much rain can also lead to bacteria, fungus, and mold grow in the soil. So when the climate change really impact on soil, especially adaptation, mitigation, and soil fertility and productivity, and it's in fact to the soil development as well. Let's talk about the oxidation and reduction in soil culture, in soil agriculture. Healthy soils rely on water, oxygen, air, and a balanced supply of nutrition. Chemical reaction within the soil can alter the physical structure of available nutrition. Oxidation and reduction process involve the oxygen exchange that takes place between water and inorganic materials. These changes affect available nutrition supply. So the reaction of oxidation and reduction happen in the soil can make the soil have different color. So the red color, they have very poor nutrition, low chroma color. Let's talk about the organic matter interaction in soil agriculture. So the availability of trace elements to plant is governed by a variety of reactions that include complexation with organic and inorganic ligand, ion exchange and absorption, precipitation and dissolution of soil, and acid-base equilibrium. A key role is often played by organic matter, both in enhancing availability to plant and in reducing toxicity effect of the free cation. Trace matter that would ordinarily convert to insoluble precipitate at the pH found in many soil are undoubtedly maintained in solution to chelation. So the base acid and base equilibrium in organic matter interaction as well. And here is the sources that we found to make this PowerPoint. You can click on there and it's go to direct to the website. Thank you for watching.